I wanted to say a big thank you to our sponsor, Talent Insights. Talent Insights are Australia's leading data specialist recruitment business. They are experts in recruitment strategy and delivery for analytics and data teams. They are the go-to recruitment business for all your data roles in Australia, and they can help both with permanent hires and short-term project-focused data resources. I've used Talent Insights in the past, and I've always found them fantastic to work with. Visit them at talentinsights.com.au. Welcome everyone to another episode of Data Futurology. In Data Futurology, we seek to bring you the discussions about the challenges that leaders in the AI, analytics, and data science space face. We give you different points of different perspectives from leaders from around the world. We hope that this helps you in advance the usage of this technology in your organization and also in your career as a career development discussion. So thank you so much for being here. My name is Felipe Flores. Today, we're going to be speaking about MLOps, about building an MLOps ecosystem. This has been a growing trend, both internationally and in Australia. We found a lot of interest and growing interest in our local industry. And I got to say, from my perspective, I'm really proud of all the work that we've done as an industry over the last few years, to increase our maturity to the point that now we're, asking about MLOps and driving that perspective, productionizing models, getting value from AI. We're, as an industry, we're hungry to improve that, and it's amazing to see. So today we're going to have a really good discussion about that. Before we jump in, quick couple of things. One is that we have, first I should thank our sponsor. So our sponsor is Talent Insights. They are our recruitment partner. They've been supporting Data Futurology for a long time. I use them when I need to recruit. I think that they're an excellent team. They're specialists in the data analytics, data science, and ML space. So if you're looking for a career move or you're looking to recruit and grow your team, give them a call. Awesome. So thanks everyone who's joining here live today. Thanks everyone who is watching the replay. I think this is going to be a really popular episode, if I call it, because I just know the caliber of professional that Ivan is. I met Ivan what it feels like 10 years ago, but it's probably like 5 or 6 years ago, and I think he's awesome. So we'll get started today. Our very special guest is Ivan Liu. He is the Director of Engineering at Rokt, and I'm super excited to have a chat with you. Ivan, how are you doing today?
I'm good. Thank you, Felipe, for the intro. I'm excited to be here, and thanks for having me here today.
Wow, amazing. Thank you so much, mate. So can you start by introducing the company that you're working on at the moment and what your role is there, and then we can jump into the MLOps side of your remit.
Yeah, of course. So I'm currently working for a MarTech company called Rokt. So it's a world-leading MarTech company providing a marketplace to offer recommendations and marketing technologies to the e-commerce website. So if you think it's technology that link both the supply side and the demand side. On the supply side, we have all the leading e-commerce website in the world, and people can shop and start their shopping journey on those websites. And they can add during the normal shopping journey, like adding the items to the shopping cart, check out. Then on the other side, whenever there's a shopping transaction moment happened at the e-commerce website, Rokt will be matching the most relevant ads to those customers. For example, if I'm buying a concert tickets in New York, and if I'm not based in New York, then a hotel discount may be showing to me. And if I'm based in New York, then a parking spot may be showing to me. So it will be totally based on your customers' behavior and cart items to provide the most relevant experience to the customers on the e-commerce website. And this can significantly enhance the shopping experience and also the happiness of the customers on e-commerce website during their whole shopping journey. And I'm currently looking after ML part of the Rokt. So our teams are developing, researching, and deploying the production level machine learning models to serve the real-time decisioning to those recommendations, bidding strategies, and upsell opportunities, all those things. There are a bunch of machine learning models to support the whole decision point. And as I mentioned, it's real-time and serving the world-scale e-commerce website. We are handling billions of transactions every year.
Amazing. And the fact that it's a service that's embedded in websites throughout the world and that it's real time, I think it just puts such a focus on MLOps and productionizing the models, making sure that they're available to interact with the customers. What is the aim for the performance of the models? Do you have a target that you expect the models to perform, say, under a set of time, or how reliable, how fast do the models need to be when serving predictions to the customers?
Yeah, of course. So as I mentioned, it's we are talking about here is a QPS. It's like a query per second in technical terms. So we will need our model to be able to serve like at least hundreds of QPS query per second, and every query can contain a list of the prediction requests in a single request and a list of candidates. For example, we have a candidate as we want to show to the user, then our model need to, for a single request, then our model need to get the predictions for all those candidates and rank them based on the predictions and show the only top relevant ads to the user. And we are talking about this with all the performance latency should be within 100 milliseconds. We are targeting it. Imagine if you are a customer on the e-commerce website and you just add an item to your shopping cart, you won't be able to wait for 2 to 5 seconds to wait your recommendation to be coming up. We want the experience to be as seamless as possible. So our model are targeting that less than 100 milliseconds P95 to get the result and show back to the customers.
Amazing. That is a fantastic benchmark, and I think also sets the context for the work that you and your team have done there. Great. So let's dive in. Maybe you can start by telling us what you see as the difference between data science and MLOps, and how they're or data science and ML engineering, how they're related, how they're different. Maybe let's start there.
Yeah, of course. That's a very good question, actually. So I'm quite lucky that because I kind of like observed the whole like evolution of the data science in industry. So I started with as a data scientist. Back to that time, there was even no data science course in uni, and a lot of organizations, they are trying to like explore the opportunities of using machine learning, data science, how they can improve the business models and business process. So back to that, I can see a lot of data scientists, they are doing a lot of things in the notebook and getting some descriptive insights, forecasting to help the support the decision making. Mm-hmm. Then big data coming in and the data science, all those things getting more and more mature. The use cases are well defined over time. People started thinking about putting all those models into the production. So it's not real like a once-off analysis. It can be continuously to help business to make the decision on day-to-day basis. And that's why the MLOps stuff become very popular at the moment. So because when we talk about continuous, things can be complicated. So if we think about in a DevOps perspective, it's all about CI/CD, continuous integration, continuous deployment. And so we can fasten the time to market for our software. It's the same concept for the model as well. So when we develop a model, we need to think about the whole life cycle. When there's new data coming in, we need to re-engineer all those data into the feature and feed it into a model and retrain the model and to capture the latest data trends and deploy it into the production. Mm. But in addition to the DevOps, it's actually it's also about the what if the incoming data quality changed or there's a drift, and what if the model we deployed into the production and changed, and So all those things are very challenging in addition to DevOps. I remember there's a very interesting discussions between our test ops team and the machine learning team. So we are trying to make sure we can test everything we can about the machine learning model before we deploy into the production. Because as you see, we are handling a large volume of predictions. We want to make sure there's no obvious risk, but it's really hard to achieve. What if there's a Black Friday happen, for example, and the data distribution from the online selling data change, and our model is trained based on last 3 months of data, for example. It haven't seen that, and those alerts we cannot really test during the regression test and smoke test, integration test offline, and we need to capture all those events. And when we identify all those risks coming from online or unknown from the real market dynamics, MLOps become very important into this space. So we are still in the early days, I would say, because you can see a lot of concepts like feature store and models pipeline stores. They are all very new concepts started coming up over the last few years. That's because we identified requirements of using those tools to control the uncertainties that traditional DevOps cannot control in the MLOps process.
Yeah, exactly. There's a lot of both new developments in the area, as you were saying, learning from the DevOps world, but also putting it all together into our own ML pipelines, including a feature store, a model store, and bringing in the observability across the pipeline and being able to see how the whole operation is working and how well and how quickly the predictions are being delivered. So the product is being delivered to the customers, but also understanding how good of a prediction is that? How valuable is it? Is that changing over time? And being able to retrain the models in ways that are tracked and that you can see what is better than whether we're being better than before. There's a lot. Yeah, there's a lot here, and I love your passion for the challenge, for moving this forward, for working in a space where productionization is so important. What do you see as some differences in either in your mindset or in the team or in the company? What are some differences when getting the models to production and getting them to run at scale, when that is your number one objective? What do you see that needs to change from what was a data science workflow environment that didn't have that push to productionization? What changes in terms of mindset or approach between when you're building a model almost in isolation between that and pushing to get into production?
I think that's a very good question, and it's very challenging. So I think when we talk about MLOps, it's not really let's say about toolings. It's more also about the process. We want to actually best practice process we want to implement in the organization. When we talk about introducing a new process, they are always about education piece and for the existing team members, and especially for the ML engineering part, because it's a very new concept. A lot of ML engineers or data scientists, they are coming from the research background. They are super good at modeling, and they can optimize the model towards very high accuracy. As things like Kaggle competitions, I've also done a few before. The winning threshold is if you provide a high accurate model, then you can win the prize. But there's also a famous case like from Netflix. They didn't choose the winning solution for productionizing eventually in the few years ago. So I think there's an education piece for the data scientists in the organization to realize that modeling is only a small proportion of the whole ML in production. And if you if you think there's a paper released by Google called like hidden technical debt from the machine learning system, you will see modeling is only a very small part of the center, and there are also data quality and the system reliability, reporting, all those different components. So which means for data scientists who want to deploy the model into the production, they will also need some basic knowledge in terms of DevOps, sometimes cloud engineering if your company is built on a cloud solution, and how to build a reporting, how to add the monitoring to your system. All those things, I would say, it's a gradual process to educate the team members to make sure they are realizing the importance of those are as same as the modeling part, and also set up some well-defined process for them to adopt over time. Mm-hmm. And it also reflects in the career and job market in the recent years. If you search the ML engineer, data scientist, you probably will see the requirements in terms of DevOps and deploy modeling productions more and more in the job ads as well. That's also because companies realize the importance of building a model plus the operational activities can bring the true value to the business.
Yeah, 100%. That's great. I might ask you about different stages of MLOps, and then we which is, I guess, different stages of the pipeline. So tell me what you think. The kind of like the stages, as I see it, is there's a stage around training and retraining models. There's a part to deploy and version the models. Then there's an audit trail and artifacts to support the serving of the model. And then there's a monitoring piece that needs to almost sit across it. And then this is kind of like a big loop, really, that where you need to be running on constantly. Does that cover the areas from your perspective? I'll ask you that first.
So just to clarify your questions, you are mainly talking about the ML lifecycle from training, retrain, deployment, monitoring, and that should be covered in the MLOps.
Yeah, and then I want to ask you more about each of the stages.
Right. Yes. So basically, there will be for the end-to-end lifecycle for the ML engineering, we've been seeing that sourcing the feature from the upstream systems and checking the data quality and the distributions, do the feature transformation, and feeding into the models for the local training. And then we will do the local validations to make sure that model is performing as expected or above the champion model. And then the model will be deployed into the productions for the lifetime serving. There can be a canary deployment because we don't really want to serve the new model for 100% traffic initially. That's too risky. Mm-hmm. And start from the 5%, 1% traffic to 20% traffic. Once we know the model is stabilized in the live system, we will promote it to the champion model. Of course, there will be a retrain model cycle, as you mentioned, because market is changing, especially when you work in an e-commerce environment. The market fashion trends are changing, event-driven things happening every day, holidays happening every day over the world. So you need to make sure your model is capturing all those events and the most recent trends happening in the market and reflecting to your predictions in a real time. And there's another part of the monitoring which is also important. So some lessons we've learned is initially when we design the monitoring systems, we are thinking about live online model performance, like log loss, AUC, all those model, actually very technical terms in terms of model. And but we think it's also important to link all those monitoring to the business metrics as well. And because sometimes your model may be performing well, but it can introduce some fairness problem, ethical problems, and maybe targeting to a certain group of people. Mm-hmm. Although it can bring the overall revenue to your business, but it's not really ideal or fair way to make the recommendations. All those considerations, it's really hard to reflect if you are only looking at overall technical model performance, log loss, all those things, and how to design a monitoring system, observabilities to integrate those business metrics as well is also important. So as I mentioned, it's still in early stage. We are identifying new requirements and things every day. And over time, I think the MLOps terms and different components will become more and more mature.
That's great. That's great. So I'll ask you to expand a bit more on some of the stages that you mentioned. So first, let's do feature stores. So how is it that at the moment that you guys are able to update the feature stores with incoming data at the speed that you need it to be done?
Yeah, that's a really good question. So I would say we are still in progress, and we've done a few POC around feature stores before. And to me, feature store is a value-added component in the whole MLOps process. So depends on your business and the stage of your business. You probably don't need one immediately, and you probably will need one. And for our case, we've observed some challenges from the online-offline data consistencies because we develop our model in Python offline, and for online serving, we have really a low latency requirements and high concurrency requirements. So we translate them into Golang or other language. In that case, the data transformation step will be different as well. So there will be challenges how you make sure the online-offline data consistencies. And that's one of the most valuable features we are looking at from the feature store. And also what I also mentioned, feature store can monitor the online feature drifting, distribution drifting, and also the incoming data distribution drifting. So because when we talk about the feature transformation steps offline, it's also a data engineering pipeline. So how we make sure the incoming data quality is not impact the model retrain and impact the quality of the model before the deployment is also important. So from my perspective, if your business is facing all those problems and you don't really have enough people to build an in-house solution to solve all those problems, then a feature store can be adding a lot of value to you. At the same time, if you are a startup or usually CTO or tech co-founder will need to be doing everything. So off-the-shelf solution or managed service like SageMaker, Google, Vertex AI can be an option to you. So again, it's a value added and also based on your business use case.
Yeah, definitely. So it's something that where models can be put into production without the necessity of a feature store, but as there increase adoption of MLOps practices in the organization and having more models in production, the need for a feature store will grow greater and greater over time. And there's definitely, there will definitely come a time to bite the bullet and make it something that can be consistent, reusable, and bring in some of the software engineering practices of DevOps into creating this data set for machine learning consumption. So that's really great. Tell me about the new models coming into the mix. So the champion challenger approach, and how is it that the models are compared? And this is, as you mentioned before, this is one of the areas where MLOps is quite different to DevOps in what this testing looks like. And then how do you tell that the new challenger is better or worse than the champion?
Yeah. So basically, our teams are actually doing the new model experimentations every day. You can see there are a lot of new versions of model with new features coming up every day. And we need to find a really reliable approach to make sure we have a better version of models to replace the current champion version of model. And we do that iteratively. So a well-defined MLOps process in place can help team to deliver their model to market much faster. So they don't need all the process can be automated. For example, there are components like model registry. There are components like model metadata services. So when you deploy a new model to the production, your model's metadata like the hyperparameters, feature list, transformations, that will be registered as well. So you can always reflect back to the models you just developed. And so the model registry can also split the traffic to your new model to 1% of traffic to make sure it's actually serving as expected and continuously monitor that 1% of traffic in live system. And then we also human need to be in the loop to make the decision if we want to promote to the 5% traffic, 20% of traffic. And then we will have a reliable report to make sure the new model is performing better than the champion model and promote it. So you can see there will, if we don't really have the model registry and the model metadata in place, there will be a lot of manual work need to be done by the data scientists and ML engineers. And they need to split the traffic manually. They need to record the log the metadata manually, and they need to record the model version manually. So that's why there's a model registry components and the metadata components to help us to have the visibilities even post the deployment. The whole journey doesn't stop at the deployment. It just starts at the deployment.
I love that. Because obviously the catchphrase in data science for so many years has been that, 80-90% of the work is on data wrangling, and then you make the model. But when you think about it from a productionization perspective, the data wrangling becomes a much smaller part of the whole process, because the game starts when we hit production. So that's great. I love that. So you were mentioning about how you split traffic and test the model, the challenger model, when kind of like live. So you do that testing in production. Is there some testing before the challenger model gets any production traffic? Is there a stage gate before that then you say, yes, this model is ready to have a 1% of traffic in production, or is it not ready yet, and does it go back? Is there a stage before that, and then is that creation of the models done by humans or machines?
Yeah. Definitely. So basically what we are targeting here is to shorten the cycle and fail fast and try fast. And we don't really want to test every model in the production. That's the goal here. So how our tool can support our machine learning engineer or data scientists to make sure they have enough confidence before pushing the model to the production is important. So for example, if our tools can be scalable and flexible enough for the machine learning engineer to do the hyperparameter tuning, to do the local validations, time-based validations, and to get the solid results locally, right before going to the live, that will be ideal. And so they can fail faster, they can stop faster, early, and try new model faster. And so that's why in our team, we also do the local validation experimentation before the live experimentation. We collect enough data, we do the hyperparameter tuning, feature testing, transformations, get the local results first, and then we will decide if we want to move to the next step or not.
Yeah, that's great. And for existing champion models, do you do any automated retraining?
Yes, definitely. So depends on different model use case. The model will be retrained by hourly, 4 hours, half day, daily. So as I mentioned, there are a bunch of different models in place, and some models, they have different seasonalities and to retrain on different intervals. And we've also did some tests to see that if you don't train model after a few hours, if there are any model degradations happening in the online. That's actually another interesting part. We want it to have the visibilities in the online system as well. So what's the staleness of your model have your model updates haven't been updated over the last few hours, we have the monitoring and alerting set up over there to make sure we have the most fresh models in the online service as well. And if we see the model degradations in terms of performance in online traffic as well, we have the capabilities to retrain the model immediately. So I think the key thing here is identify the risks and also the requirements of monitoring observabilities and provide those visibilities to the ML engineers so they can make the decision, inform the decisions based on those data.
Yeah, that makes sense. So then that makes a lot of sense, because then you're capturing the metrics. All that is being done in the or do you see that as being done in the model store, then where we have the model versioning, the registry, the metadata, and also the deployment and monitoring? Is that all part of model store, or are they different?
Yeah, we are currently doing it in a different way. So we have the model pipeline orchestration services, and ML engineer can easily deploy their pipelines on their services, and it's highly scalable. And you can do the hyperparameter tuning, you can do the local experimentations, you can schedule the new models on that. And then the metadata will be saved in a separate services for monitoring and the online experimentations later. And they are currently separate services at the moment, but different companies may have different ways. And I think some business or some teams, they actually building the pipeline together with MLflow integrate together, so the model registry and the metadata can be controlled by the pipeline service as well. So there are multiple different ways we can achieve that.
Yeah, that makes sense. That's really good. And what is your ML pipeline and orchestration tech look like?
Yeah, so we are currently using the QFlow, and which is like ML pipeline platform on top of the Kubernetes. And I think Rokt probably is one of the first companies in Australia who has productionized it. And when we make that decision, there are multiple options. So because there are already some managed service in the market like SageMaker, and people can use those service directly. And it depends on your team's skill set, because our teams are quite actually T-shaped skill set. So they know the cloud engineering quite well. Before the QFlow and Kubernetes coming in, we've already started deploying the pipeline in the EC2 instance and spin up the CloudFormation infrastructure for those pipeline scheduling. So they have the basic knowledge around the cloud engineering and also DevOps, all those things. So it will be easier for us to build in-house solutions based on open source tools like QFlow. And there's also a consideration about if you want to bond it with a single cloud provider. If you see your company have a multi-cloud strategy, so then open source tools can be a more feasible ways to make sure your machine learning pipelines deployed and developed more portable. You can easily migrate that pipelines from this cloud provider to another cloud provider and make it more shareable between the team members, because the source code are version controlled. And if you have other team members who want to share the same components, like training components, feature components, then they can use it directly as well.
Yeah, that's really good. That's really good. So this is a good segue to the skill sets. Maybe I should ask you first, what type of skill sets do you think ML engineers need and to do MLOps?
I think in short term, data engineering, cloud engineering, DevOps, those things are basic knowledge. I think they are actually quite necessary. So I would say it actually depends. If you think it's necessary for you to build a MLOps teams in the teams, for example, you want to build your own feature store, model pipelines in-house, then MLOps teams will need knowledge in terms of DevOps, cloud engineering, data engineering, of course, machine learning. You need to understand the machine learning from a life cycle, training and testing, feature engineering, all those things. I know it's very hard to find such people at the moment in the market with such wide skill sets, and it's also been a challenge for us as well. But I think we are building a team, not like a single developer, superstar developer. So if your teams have those skill sets together, and the team can learn from each other, improve from each other, I think that's enough to build an MLOps team. And by saying that, if you decide to go with those managed services, I don't think we are quite there at the moment. There are a lot of feature store service, model pipeline service out there. You can use them directly, but I found a lot of integration challenge, security challenge you need to deal with internally again. And I hope in future, when those tools are more mature, like in DevOps space, you probably don't even need a MLOps team. So your machine learning engineers can be more specialized in the machine learning, probably less knowledge in terms of other side of things. They will become a tool, from a tool builder to a tool user in that stage.
Yeah, nice. That would be great. And this is the skill sets as you were describing. It's also quite related to the team structure. So I wanted to get your views on the team structure. That some organizations have a separate data science team from the ML ops team or the ML engineering team. Sometimes they're different, sometimes they're the same, sometimes they're grouped with other specialties in a cross-functional team. And obviously it's horses for courses, but what are your views on team structures in this space?
Actually, I don't have a definitive answer on that because I've seen successful story for both cases. And I've seen there are like data science teams building a model, do research in the model, then hand over to the ML engineering team for deployment and the maintenance, for the model maintenance. I've also seen the successful story, which is actually working at Rokt. Our teams are actually owning the end-to-end process from the research deployment to the maintenance to the live monitoring. And it went quite well. So, and there's a culture at Rokt, yes, you build it, you own it. If something happening in the live system, you need to get up and respond to it. So I think, it's more like from the organization level, I would say, and also your team skill set. If organization level, you have a culture like this, decentralized, every Scrum teams own their own product, and then I will go with the end-to-end approach. And also, if your teams are willing to learn those skills from apart from the machine learning, and your teams are more T-shaped style, then I will also go with the end-to-end approach. But it doesn't mean that if you only have, it doesn't mean that the other approach is not good. It's just a choice to fit your business model and the team skill set. Yeah.
Exactly, yeah, and the maturity of where the team and the company is at that point in time. So that's really good. And in your case, is your team a product team, or as in like, does it have is it a cross-functional team from people across the organization, or is it a data science and MLOps, ML engineering team?
Yeah, currently we have one team doing everything. So, and because we do observe the requirements of building those tools in-house. So we are working heavily with SRE team, for example, to make sure that our QFlow cluster is reliable. We are working heavily with real-time service teams to make sure our real-time services are reliable and can be fed into the front-end services. And there's the potential needs for us to build MLOps teams to just build up those in-house feature store and model pipeline tools. If we are not choose to use the managed service or existing tools external. Yeah. So I would say your teams will be looked after end to end, ML, but you still need to work heavily coordinate with heavily with other engineering teams as well.
Yeah, that makes sense. That's really good. What do you see as some of the maybe unanswered challenges in the MLOps space? So what is something that is either too painful at the moment, something that you would like for it to be done more easily? What are some pain points, I guess, in the MLOps space at the moment?
I think a lot of tools are maturing at the moment in this space, and which is good. But we've seen some challenges that a lot of open source tool or managed service tools, they don't underestimate your efforts you need to put if you want to use a managed service or open source tools in your team. And we found a lot of customizations or even development will required internally to build up that tools and integrate with your existing system well and to be usable for your ML engineers. And I think that part is very challenging because eventually I will expect that those tools can be as good as some existing DevOps tools that can be set up by your own teams easily. And you don't really need to set up a new team to set up, config, maintain those tools on a daily basis. So I think that's something the whole industry and the whole MLOps industry are improving and maturing over time.
Yeah, that's really good. And how do you recommend people to get started in the MLOps space? So if people work at organizations where they've created some models, maybe they're running them in a batch way against a database, and writing the predictions back to a database, what do you see as their journey from there to real-time serving of inferences?
If there are some existing framework out there, for example, the feature store, and they read the product documentation, they have the solutions to real-time online data, then you will probably get some ideas about the challenges you might be facing. For example, if you are moving your batch predictions into online services, feature store documentation will tell you they are solving the problems like online, offline consistencies, and you will get an idea why there might be a challenge I might be facing if I move from the batch service to the online services. And there are a lot of use cases in the industry. And I think Google also released their white paper in terms of the best practice of the MLOps on their platform. Azure does and AWS does. So I would say just track the latest news from the industry to see, because MLOps process is currently very different in companies at the moment. Mm-hmm. We are all at very early stage, especially also in Australia. I've seen people are improving it, learning it, and identify the risks. I wouldn't expect I can cover everything while I design. So when I design the process or design the system, I expect it will be replaced in 1 to 2 years. And when there's new toolings coming up, when there's new business challenge or business requirements coming up. So just to keep a close eye on a successful story and be prepared to react to all those challenges you might be facing and unique to you.
Yeah, really nice. Tell me a bit more about QFlow, and then maybe introduce it for people that might not know it. Tell us a bit more about it, and then also how you ended up choosing it, and maybe we'll start with that. Then I'll ask you more about the journey.
Yeah. So QFlow is interesting one. So I actually started using QFlow around 2 years ago when it was still in 0.6 version, and it was pretty not mature tool back to that time. And then in the latest year, they released 1.3, 1.4. It's become more and more mature. And that also reached a stage that we think we can start using it.
Mm-hmm.
And the good thing is it's actually built on the top of the Kubernetes, which is, can support your machine learning models to be highly scalable and reliable. If your job is failed in one component, you can quickly spin up another pod and retry the components to it. So it provides a lot of benefits. But as a tool, I think you will need to do a lot of customizations on it. And it's still not mature enough. And there will be a lot of work you need to plan, efforts you need to plan, and work between your teams and the SRE team to make it reliable enough. So, but the main decision we are making is it's an open source tool. There are not many open source tools out there to help you do the pipeline orchestrations. And I know some companies are using Airflow, and we are using QFlow, but there are not many more options you can choose if you choose to not highly bundled with one cloud provider. So that's the main reason behind that. And we are confident about our teams can actually learn the Kubernetes, do the work on the Kubernetes. So yeah, that's why we choose QFlow. You mentioned.
Yeah, really nice, really nice. You mentioned Airflow. I thought Airflow was for a data orchestration. So it's moved into the ML orchestration as well. Yeah,
I know in some companies they are using Airflow to trigger the spin up the instance for the model training as well. So I totally agree. It's a lightweighted compared to the like QFlow.
Mm-hmm. Yeah. Oh, nice. Yeah, that's really nice. Good. And what do you see as the evolution of the industry as we've gone in this journey from data science and building the models to now getting into production, getting into used by business? We're kind of like early stages in this part of in this stage in the journey. What do you see as coming up in the evolution of the industry and where we're going?
I would expect that there are more and more end-to-end solutions, MLOps solutions coming up, and in the next few years. And there are a lot of for the independent services like feature store and the pipeline monitoring coming up as well. And a lot of those companies are getting fundings, and it raises a lot of interest in different companies to use those solutions. But I personally will expect if there's a unified solutions in future and to cover the end-to-end. So rather than focusing on one stage of the machine learning lifecycle. And in that case, as a team, we don't really need to spend extra efforts to build those in-house tools by ourselves. We can implement it. It should be make ML engineers' life much easier to just leverage those tools to do their actual work in machine learning modeling and deployments, rather than focus on those ops level works.
Yeah, really nice. We just had a comment from Nako, which I think I can put on the screen. Yeah, where he was saying that really, really good thinking about refreshing the technology and the approaches in one to 2 years. That some organizations find it difficult to do, and sometimes they stick with tools for a long, long time. Do you have any advice for organizations that are looking to break the habit and jump into the newer space?
Yeah. So I think I've also observed such situations, especially for those large organizations. They may design a system like years ago and many decades ago. Actually, the documentation may not be fully maintained, or even the initial developer have left the positions. So in those cases, the migration is really hard. So I think for at least for newer systems, we have the ideas of design in iterative ways. We don't expect it to design a perfect solution. We don't follow the waterfall approach initially. So we expect that we will iteratively improve the systems and make it flexible. And this reflects in the service architecture microservices, and they are self-contained, fully adoptable, and testable and migratable. So it's also I would say it depends on how what's the architecture approach in your organization to achieve those engineering problems, and it's become more and more popular in recent years in different organizations to make sure they are system designed in a adaptive way.
Yeah, really nice. And man, what keeps you passionate about this space? Like what drives you, and has it changed in terms of what drove you into the space when data science was just coming up as a term, and you were ferociously doing online courses and working to become the best data scientist that you could? Has it changed? Has your passions or your motivations changed between the start of the journey and where you are now?
So my background initially was in BI and data warehousing. So I found using those data to support the decision making, to improve business model process really excites me. And then I move into the predictive part. So I think predictive modeling to support decision making is also very exciting to me. So, and that's how I move into the machine learning and statistical modeling space. And then during that journey, I found it's super excites me to land all those predictive models into the real business use to provide continuous value to the business, optimize the business process over time. And then MLOps, how to productionize, coming into my side. So I think it's also a learning journey for me. Start from a small thing to more and more bigger and bigger things to me. And that's why eventually I found it's really what motivates me is to actually land those disruptive and AI-based solutions in real world, and to see how they can make a difference to the business or to even to the life, to the people. That's why I also co-founded a few startups during my spare time to build AI-based startup to build AI-based solutions to change the existing behavior or provide more values to the people.
Amazing. And what applications of AI are you particularly excited about? Anything that you would like to either see come into reality, or things that are happening that you're particularly excited about?
Yeah. I personally quite excited about the object detections and also the voice NLP side. So those unstructured data that cannot be handled easily by human and which can be processed by AI, provide innovative solutions. That's actually very excites me. So, for example, the chatbot, the visual search, all those things, just open a new way to the people to how to do their current daily things. For example, if every people is doing like a Google by using text at the moment, what if we search it by the image, by what you've seen, and it give you much better results, or provide the context that the text cannot be providing? Or what if you search by the voice, by the sounds that the text cannot be providing? All those new dimensions that we can open for people to change their lifestyle or change their ways to make their life easier, that actually very excites me and motivate me to do that.
Yeah, that's really good. Yeah, there's been obviously amazing progress in that space where some of the recent projects coming more out of the research stage or prototype stage is some of the ones that I've seen is people being able to describe a web page that they want and have an AI build the web page and doing kind of like that natural language to code to then rendering it, and it's really really exciting. We've got a comment from Sandhya, which I might put up on the screen. Great. So she says, I think there's an apprehension in investing and trying MLOps in many companies starting out their ML journey, as the tech landscape in this space is changing rapidly and one might have to change or replace tech. I agree. There's definitely like a perceived sense that there's a high barrier, and there's a lot of complexity and a lot of new tech to acquire, enable, and then leverage in order to get to this point. What do you think about this apprehension in investing and trying MLOps from companies, Ivan?
Yeah, that's what I've observed as well. So that's happening a lot after we identify the use case and the values that ML can provide to the business. So I think we passed the stage of the data science and the ML hypes, and we've got a very solid use case that ML can help the business how to improve their process and values. And that's why MLOps companies are willing to invest in the MLOps to add that in a BAU process into their business. And yeah, I totally agree with that.
Yeah, I agree. It's an area that obviously is getting a lot of investment. It needs to become easier for the world to be able to leverage AI better and more of it, because we've had, at least from my perspective, we've had so many models historically being created, and often good models that sometimes don't get to see the light of day or don't get to interact with customers in a real life setting at scale and with in very near real time. And that's the part that today it takes a lot of tech effort to get there, and it needs to become easier for more of us to be leveraging ML and AI in more parts of our lives. So that's a really exciting journey I think we're on at the moment. Awesome. Mate, thank you so much for coming on the show, for sharing all your knowledge and perspectives. The work that you're doing is amazing, as always. Like as I mentioned at the beginning, I've known Ivan for a number of years, and I'm always impressed at the work that he's doing. And I feel like he's always trailblazing and definitely ahead of the curve. So I was very excited to get you on the show, mate, and to get you to share your journey and perspectives with everyone. Also excited that you're coming back for the MLOps event on November 17th. So Ivan's going to be in one of the panels there. So check the website for more details. November 10th, we have the AI ethics event. And on November 17th, we have the MLOps event, which will be from mid-morning to mid-afternoon. So that'll be really, really great. I want to thank everyone who joined us live today, everyone who's watching the replay at home. I'm getting some thank you messages. Thank you so much. Thanks everyone who joined, and Ivan, thanks again. Hope to see everyone in the next session. See you all next time.
Thank you, everyone. See you.
Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.